Picture this. It's Friday morning. You have just about powered through another grueling week of work and studying. You decide to reward yourself with a cup of hot coffee and a bowl of your favorite cereal before you leave for work. When you're finished, you carry the empty white bowl to the sink, but you trip over a carpet edge and drop it. Great, you say to yourself. What a wonderful way to start my Friday. Noticing the time, you rush to clean the mess of broken glass and soggy cereal that has scattered along the tile floor. But in the rush, cut your finger deeply. Looks like there's no work for you today. Off to the doctor you go. When you arrive at the sterile-smelling doctor's office, you start to explain to the doctor what happened. But while speaking, your speech starts slurring. Now the doctor is getting concerned. He starts asking if you seem to be dropping a lot of things lately, and if you feel weak at times. Thinking, you finally answer, yes. Next thing you know, you're being rushed off for tests. A week later, the phone rings. It's the doctor's office. You've just been diagnosed with ALS. ALS, amyotrophic lateral sclerosis, is a progressive neurodegenerative disease that affects nerve cells in the brain and in the spinal cord. You may better know this disease as Lou Gehrig's disease. This disease, motor neurons reach from the brain to the spinal cord, and from the spinal cord to the muscles throughout the body. The progressive degeneration of the motor neurons in ALS eventually leads to their death. Sadly, people in the later stages of ALS are likely to become completely paralyzed. Even though individuals with ALS are paralyzed, some are still able to gain crucial independence even though they can't necessarily move their muscles. How? The answer? Brain-computer interfaces. A BCI system detects electrical signals produced from the human brain and converts them into control signals to operate a device by reading the user's thoughts. BCI technology was not the goal when Hans Berger developed the EEG in 1929. However, it was his technology that has led us to where we are today, and for that he does deserve some credit. Years passed, and in 1987, Philip Kennedy founded Neural Signals Incorporated. Kennedy, who holds both an MD and a PhD, personally funded the company's initial development of a novel implantable device for detecting and transmitting signals from the cerebral cortex. After successful animal trials, the FDA granted Kennedy permission to implant the device in humans, and the first device was implanted in 1998 to a patient who was totally paralyzed. With months of training, the patient was able to control a cursor with his mind. In 2001, John Donahue, along with other researchers, established Cyberkinetics, which is a company to commercially develop his brain-computer interface called BrainGate. In June 2004, history was made with Matthew Nagel. He was implanted with Cyberkinetics BrainGate. He was the first human to be implanted with BCI technology. So, how does it work? BCI technology has rapidly improved communication in individuals with paralysis. BCI systems help with communications in a way that no other system can. For example, individuals with ALS sometimes have trouble speaking and communicating their thoughts. BCI technology can transform those thoughts into brainwaves. The computer can then analyze the waves and in turn write emails, send text messages, or even move prosthetics. The ever-evolving BCI, anything that can be controlled by a computer could in turn be controlled by a BCI. In fact, researchers are working with a prototype design and implementation of an automatic control system that's based on a BCI. They are specifically proposing a prototype of an automatic control system that controls vehicle sensors through the application of a BCI to a vehicle system for a remote sensor control. BCI technology not only enhances communication, but can also be used to control a program that is running on a computer. This type of technology is known as a screen overlay control interface. This would be extremely useful for things such as video games. Another form of BCI technology, and my personal favorite, is a more artistic interface. This technology now enables its users to be able to paint and draw, taking back parts of life many thought they'd lost forever. The user reacts to flashes on the screen, which mean different colors and designs. This is known as a painting by thoughts interface. So how do they fit? There are two ways to fit a BCI, invasive and non-invasive. Both ways require electrodes to transfer the signal from your brain to the computer. An invasive BCI requires the electrodes to actually be surgically implanted closer onto the surface of your brain. A non-invasive BCI, their electrodes are connected to your scalp. The electrodes are then connected to a computer, which reads the transmitted information from your brain and computes it. When first researching BCI, I, like many others, assumed it was a mind reader. This is not the case. BCI uses what is referred to as triggers to transmit information. The ALS Foundation summarizes this technology very well. I quote, "Most BCI spelling systems display a series of letters, either one at a time or by highlighting letters in a grid. When the letter you want lights up, your brainwave changes. The computer looks for that change and interprets it as a keystroke. For example, if you wanted to type the letter A, you would focus on the A and count each time it flashed, or think yes. When you saw it appear on the screen, recognizing the A would trigger a spike in your brain signals, which would be detected by the BCI system. Usually, each time the letter must be selected multiple times, so typing with the BCI is slow, and often they try to use common words instead of individual letters to speed things up. Systems designed to control a computer cursor often rely on movement imagery. You would imagine squeezing your right hand to move the cursor to the right and your left hand to move the cursor to your left. This example summarizes the technology of a spelling system, BCI. So, who uses them? Currently, BCI systems are challenging to use, therefore they're not recommended for everyone. People who would most benefit from a brain control interface include those with advanced ALS or those with little or no reliable muscle movement. Brain-computer interfaces are also expensive, averaging around $5,000. As of yet, only a company called Intendex is allowing the purchases of the spelling BCI, the overlay BCI, as well as the drawing BCI. Right now, technology is not covered by the insurance, but that could be changing in the near future. As with all things, the groundbreaking technology will evolve and adapt with time. Brain-computer interfaces will continue to become more efficient, accessible, and fiscally attainable. With unfortunate circumstances, it's refreshing to know that there are solutions being explored to help people cope. These ever-evolving technologies are helping people every day return to rushing off to their hectic Friday morning.